So we're going to be looking at graphs of quadratics and quadratic functions in a different form. We're going to look at it in the vertex form, where y is equal to a, and then in parentheses, x minus h parentheses squared plus k. In other words, it's sometimes you have to complete the square like we've done before to get it in the proper form. When it is in this form, h and k is your vertex. So the opposite of what's in the parentheses and the same as what's on the outside is your vertex. Now also remember that your axis of symmetry goes through the vertex and it's x equaling the x-coordinate of the vertex. Now we're going to be asked to find the vertex, axis of symmetry, direction of opening, and how the parabola is translated from your basic parabola for each one of these others. So your vertex is always the opposite of what's in the parentheses, so it's going to be positive 3, the same as what's in the outside, which is 2. Your axis of symmetry is always x equaling your x-coordinate of your vertex. Now how it's translated, your vertex on this one right here is at 0, 0. Our new vertex is 3 over and 2 up, so it's translated 3 to the right and 2 up. Now, remember from what we've done before, we want to go ahead and put your table, middle of your table is your vertex or axis of symmetry. Then choose a couple numbers on each side. In the past, we chose 3 numbers on each side, but in this case, I only chose 2 because it goes way off my graph. And then you can plug those numbers into your original problem to be able to find your y values. Then all you have to do is plot your points, which you can see over here. Now, that's one way to do it. A second way you could do it is follow the pattern. 1 over, then you go up 1. 1 more over, then you go up 3 more. 1 more over, then you go up 5 more. 1 more over, and you go up 7 more. Now, you should be able to also see that looking over here if you were to continue this pattern. From here to here, you went that up 1. And then from here to here, you went up by 3. That's this here. If you would have went and plugged in 0, which would be easy to do, you would then get 0 minus 3, which is negative 3 squared, which is 9, plus 2 is 11. You would have been at 0 and 11. So then you can see that you go from here to here, you would have been going up by 5, which correlates to this. So looking at your graph, over 1, up 1. Over 1 more, up 3. Then it would be over 1 more, then it would be up 5 for your next point. So you can use that pattern if you want. Now keep in mind, if there is a 3 in front of your parentheses, basically you just have to take that number in front of your parentheses times that pattern of 1, 3, 5, 7, which is just the odd numbers. So to go from this form to the vertex form, we have our standard form to the vertex form, we have to complete the square. There's a couple ways you could do that. One of the ways is similar to what we've done in the past in completing the square. You want to get you're trying to complete the square with the x's, so you got to get your variables on one side by themselves. So you got to get the x's by themselves, so subtract 4. So in other words, you get y minus 4 is equal to x squared plus 2x. Then you want to go ahead and complete the square. So you want to take half of b, b is 1, take half of that and square it. So you go 1 squared here and 1 squared here. So in other words, on the left you get a y minus 3. Remember when you do, after you do that half of b squared on both sides, it factors into 2 identical parentheses that are both the same. What's being squared in the beginning is x. What's being squared in the end to give you 1? Well, that's a 1, so that goes there. 2 identical parentheses you could write as 1 parenthesis squared. Then you want to get y on one side by itself. So you now have it in the correct form. A second way you could have done it to complete the square is you could have just grouped the x's together. And by the way, remember if there is something in front of your squared term other than 1, we'd have to deal with that too. Then we want to go ahead and get ready to complete the square. So in here I left a spot to go plus half of b squared. So in this case, I'm going to take half of this, which is 1, and then square it. Well, if I add it here and I stay on the same side of the equal sign, I have to have a net change of 0. So if I add a 1 squared here, I then need to subtract a 1 squared. Now you might be wondering if I add a red 1 squared and subtract a 1 squared red, why is there a blue 1 hanging around? Because whatever's in front of your parentheses affects what's in here. And while the blue 1 times this doesn't really change it much, but just be aware that if you had a number in front, it would have to be hanging out here, and that would make a difference. You factor the parentheses into two identical parentheses, or you can write it as 1 parenthesis squared, and then you get 4 minus 1, which is your 3. So we get the exact same answer that we had over here. Your vertex is always opposite of what's in the parentheses, same as the outside. Axis of symmetry is always x equals whatever your x coordinate is, and because it's positive in front, we open up. Then we could graph it by going to your vertex, then go over 1, over 1, up 3, and so on. So here, let's go ahead and practice this one. Now this one's a little bit harder because we have a number in front of our square term. So you could go ahead and divide both sides by that -3. Well, if we do that, we get this. Well, then you want to get the x's by themselves, so you'd have to add 4/3 to both sides. Well, if you do that, you get this. Then you'd have to go half of 2, which is 1. And that's what you have to go ahead and square to both sides. Now on the left side, I wrote that as 1 fraction. So take half of 2, which is 1, and that's what I add, and I square to both sides. So the right-hand side we know is going to factor into two identical parentheses. X is what's being squared here. What's being squared to give you 1, which is 1. Left-hand side, this is 3 over 3 plus this to do a common denominator, so we get this here. Then you want to try to get y by itself. So you'd have to undo the dividing by 3, so multiply both sides by 3. Then you'd have to undo the plus 7, so subtract 7 from both sides. Then you'd have to undo the negative in front of your y, so divide both sides by -1, or to multiply both sides by -1. So it's going to put a negative in front of this, and it's going to switch your sign on the 7. If you had done it the second way, you will still get the same answer. However, you're going to go ahead and just group your x's together. Then we want to have a 1 in front of your squared. So you're going to go ahead and pull that -3 out of just the x's, because we're completing the square with the x's, so we're only pulling it out of the x's. So now that -3 is going to be there in front. We take half of the 2 and square it. Well, half of 2 is 1. That's what we squared and put here. If we add it here, we have to subtract it here. That's why it's minus your 1 squared. But remember, it's a -3 times everything in parentheses. So we added a -3 times a 1 squared, so we have to subtract a -3 times a 1 squared. So here we'll bring down our -3. This is going to factor just like it did on the other one into an x plus 1 all squared. So now we have our 3, and we're really subtracting a negative, which is adding a 3 times 1, or 4 plus 3, which is 7. So we really get the same answer that we had before. So for your vertex, it's the opposite of what's in the parentheses, same as what's in the outside. Your x-coordinate is always, or your axis of symmetry is always equal to your x-coordinate, so it's x equals that. It opens down because we have a negative in front. So you could be right here, then you could go over 1, down 3, over 1, down 9, because you're going that 1, 3, 5, 7, multiplying it by that number in front. So here we're trying to find the equation of a parabola when we know its vertex, and then we know a point that it passes through. Well, if we know our vertex, I'm going to choose to use my vertex form, because there's 3 things I won't know. If I use standard form, like y equals ax squared plus bx plus c, I won't know a, I won't know b, I won't know c. If I use the vertex form, there's still 3 things you have to find. A, h, which is the x-coordinate of your vertex, and k, which is the y-coordinate of your vertex. And since we know our vertex, that means we already know two of the three things. So we plug in h being -1, k being 4, we get this. Hey, we're 2/3 done. All we have to do is just figure out that one of the three pieces we don't know. So all we're going to do with this is take and plug in our point, because your point is an x, comma, y. So your 2 would go in for your x, your 1 would go in for your y. Well, if we do that, we would get this here. Then all we have to do is solve it. 2 plus 1 is 3. We square that. Now notice your 9 is multiplied by the a, so you cannot combine it with your 4. So now you have to get your a by itself, so subtract 4 from both sides, divide by your 9, you get a. Now we had figured out h and k a little bit ago. We just figured out a. So all we're going to do is rewrite this equation right here, just with the correct value of a plugged in. And that's what we get right here.